Okay, Assalamualaikum and dear students, let's discuss together example secant method. So I chose one example in order to give you an idea on how the secant method works. Okay, so I choose example 2.22. Find the root of ft equal to this one. Okay, actually we already looked at this example in force position methods, but now we want to solve or finding roots by using open method, which is secant methods. All right, with the initial guesses. So this is our initial guesses. So in secant methods, the initial guesses not necessarily bracket your roots, means that you can choose any initial guesses, and the methods we calculate. Okay, but in terms of convergence is not guaranteed. Okay, however, if secant method converge, then normally it's converge faster compared to the methods in bracketing methods. And then you ask to perform the computation until your approximate percent relative error less than the given stopping criterion 0.5%. Okay, so now let's solve this together. The solution. Okay, so we start with first iteration. Alright, so this is our first iteration. So first iteration, we have the initial guesses t subscript -1 equal to 3, and t subscript 0 means t naught 3.5. Okay, so first we calculate f t -1 means that f3. So if you substitute into your function, okay, this should give you, if you use your calculator and you write in 4 decimal places, you should get 1.8035. And then next you calculate f t naught. F when t naught is 3.5. Okay, so this will give you 0.7761. Okay, so now we start calculate our first root estimation by using the secant method formula. Okay, so the formula is ti plus 1 equal to ti minus fti times ti minus 1 minus ti over fti minus 1 minus fti. Okay, so now we calculate. So for first iteration, I equal to 0. Okay, so that way we have t1 equal to t naught minus ft naught multiply with t minus 1 minus t naught, okay, over ft minus 1 minus ft naught. All right, so now we substitute all the value, okay, all the known value. So we have here 3.5 minus 0.7761 for FT0, and then 3 minus 3.5. Okay, so here 1.8035 minus 0.7761. So if you use your calculator and then you set into 4 decimal places, you should get 3.8777. So this is your T1. And then now we calculate approximate percent relative error. For our first iteration, it's come from T1 minus T0 divided by T1 multiply with 100, and then you put the percentage. So in secant method also, we can calculate approximate percent relative error at early first iteration. Okay, because we already have previous value, okay, previous value which is come from our guess. Okay, so here give you 3.8777 minus 3.5 over 3.8777, and then multiply with 100%. So here you should get 9.74%. Okay, so this value is greater than the given stopping criterion, so that we need to continue to the next iteration process. Okay, so for second iteration, we will use the information from T0, which is 3.5, and T1 that we calculate previously, 3.8777. Okay, so FT0 we already obtained in our first iteration, so I just write the value here. Alright, and then calculate your FT1. So you have F 3.8777 here, and then you substitute 75 exponent negative 1.5 multiply with your T1. Okay, so this should give you your FT1 equal to 0.1762. Okay, so now in second iteration, I equal to 1, so that we can calculate our next roots estimation. T2 equal to T1 minus FT1. Okay, multiply with T0 minus T1 over FT0 minus FT1. Okay, so you substitute all the value, known value. T1 3.8777, and then minus FT1 0.1762 multiply with T0 3.5 minus T1 3.8777. Okay, and then divide with FT0 0.7761 minus 0.1762. So this you should get T2 equal to 3.9886. Okay, so this is our value for our next roots estimation, T2. T2. Okay, so if you calculate your approximate percent relative error, so now you have T2 minus T1 divided by T2, multiply with 100, and then you put the percentage. Okay, so substitute all the known value here. Okay, multiply with 100%. So by using your calculator, you should get 2.78%. So again, this value still greater than the given stopping criterion. Then we need to continue to the third iteration. Okay, so now continue third iteration. Alright, so this time we need this information, T1 3.8777 and also T2. Okay, our previous roots estimation. Alright, so FT1 we already calculated the value. Okay, so for FT2, okay, so substitute into your function. So this should give you your FT2 equal to 0.0182. Okay, so at this third iteration, I equal to 2, so that we can improve the root estimation denoted by T3, where the value is come from T2 minus FT2 multiply with T1 minus T2 divided with FT1 minus FT2. Okay, so this is the secant method formula. Okay, so substitute all the known value. Alright, okay, so this will give you T3 equal to 4.0014. Okay, so now this is our new roots estimation. Okay, so now we check again with the stopping criterion. So calculate your approximate percent relative error from your updated root estimation. Okay, so now we check T3 minus T2 divided by T3. Okay, so we have here 4.0014 minus 3.9886 divided with 4.0014, and then we multiply with 100%, and then if you calculate, you should get 0.32%. Then luckily we achieved the stopping criterion, because the stopping criterion is 0.5%. Therefore we need to stop the computation process. Okay, right. Okay, so actually we can summarize our solution in table, or you can also use table at this beginning of the solution. Not necessarily you show step-by-step calculation. If you are really confident with your calculation, then And also to save time, you can straight away present your solution in table. Okay, like what I summarize here. Okay, so if I summarize the solutions in table as follows. Okay, so if we summarize in table as follows, so at this point is the calculation of secant methods. Okay, so here is our secant method formula is here. Secant formula. So at this column here, you calculate by using secant method formula. Okay, so look here. This is our first iteration. Okay, so I substitute already. Okay, so in second iteration, I want to give you the idea on how you want to save your time if you summarize or you present the solution by using table. So in second iteration, all right, I equal to 1, then for ti minus 1 means I minus 1, 1 minus 1, t naught. So previously, here is value of your t naught. So this value move here. Okay. And then now this become t1. So where is your calculation for t1? So previously, this is the calculation for t1. So if move here, 3.8777. And then this value you bring here because this is the value for f t naught. Okay, previously this is your f t naught. All right, so now it's become here, so 0.7761. okay, so this value you need to calculate in second iteration. So based on our previous calculation, we obtain 1762. And then by using secant method formula, okay, you must use calculator, and then on our computation we get 3.9886, and then here is 2.78. so still greater than stopping criterion, then we need to move to next iteration. So third iteration, I equal to 2. All right, so this time, okay, this time when I equal to 2, ti minus 1 means that 2 minus 1, so t1. So previously here is your t1, so this value move here, 3.8777. So at this column here is ti, so t2. Where is your t2? This is from the secant method. Previously you get your t2, so you move here, 3.9886. okay, and then this value here is belong to ft2, right, previously. So sorry, this belong to ft1, so you bring here, so 0.1762. so means that in the next iteration, only these two columns that you need to update the value. Okay, because the other part you already have the known value from the previous iteration. All right, so that's why I said that by using table you can save a lot. Okay, but you must to be confident and very focused, and also good in your calculation. Okay, try to avoid minor mistakes. Okay, that's why you need to do a lot of practices. So from our calculation, ft2 give us the value 0.0182, and then by using secant method we calculate our t3, so we obtain 4.0014, and then approximate percent relative error give you 0.32%, which is less than stopping criterion. Then we stop. Okay, so as I mentioned, you need to conclude your solution, because from this table you must to tell us, your examiner, what is actually your answer, what is your roots, your approximated roots. Okay, so make a conclusion. Therefore, after 3 iterations, okay, the approximated root of fx equal to 0, sorry, it's not fx because we talk about ft, so I write this as ft equal to 0 is t equal to, which one is your solution? Okay, which one is your root? Look here, okay, this value here. So t equal to, okay, sorry, this should be your solution, sorry, it's my mistake. Alright, t equal to 4.0014 with approximate percent equal to 0.32%. Okay, then complete our solutions. Okay students, so this is the graphical illustration by using Mapper. So Mapper is actually one of the mathematical algebraic software. Okay, so if I plot our function by using Mapper, so this should be your graph. Okay, so you can see here, this is our aim. Okay, we try to estimate this root. Okay, so from the graph, this graph, you can see that this function equal to 0 when x is about when t is about 4, equal to 4, right? Okay, so you can see previously in our solution we obtain our root is 4.0014, means that our approximation is very close to the true solution. So that's why you can see here our approximate relative error also reduced, means that the solution converge. Okay, okay, so then this is how the behavior or the words, okay, done by the secant method procedure, the calculation what we did previously. Okay, so A and B here is our initial guesses. Remember, 3 and 3.5. So you can see here, secant methods not required to bracket your roots because the true solution is here. Okay, but the selection of initial guesses is outside our roots. Okay, did not bracket our roots. So this is the properties of open method, not required to bracket your roots. So this is how the secant methods. Okay, remember when I explained on the formulation, so this is our secant line. The blue color is the secant line. Okay, so we calculate by using secant method, and then we extend or we extrapolate this secant until we teach or cross the x-axis. So this is our first iteration. So this is our first roots estimation. Okay, then the next process, second iteration, we have this and this, we have another secant line. Okay, we calculate and then we update, so we get here another green circle here for our second iteration. And then third iteration, we have another secant line here, we calculate until we get the value for P3. So P3 is 4.0014 that we calculate here. So this is actually our P3. Okay, so basically this is the idea of secant methods. Okay, so I hope my explanation can give you idea, and if you have any problem, do not hesitate to contact and discuss with your lecturer. Okay, until the next video, thank you so much.